Okay. Well, hello everyone. My name is Scott Grisard, University of South Florida. This is the review for quiz calculus. The review for quiz 8B. As usual, we are on Twitch chat. We are in Blackboard Collaborate Ultra chat. If you want your chat to be private, Blackboard Collaborate Ultra chat, please. And we will have polls on Blackboard Collaborate Ultra. Okay, so this first problem here, there we go. This first problem here is asking you to do, the first part is I need the lines at x equals 1 and x equals 8. And I've drawn the little things here. Oops. So these lines that are tangent here to the curve at those particular points. So I need this one here, and I need this one here. It's about there. That's about it. Okay, so those are the two lines I need. This one is here, tangent to x equals 1, and this one is tangent to x equals 8. Okay, so how do we feel about that? I see there's a question, but I can't get to it right now because I got the poll thing up. Give me 1 second. How do we feel about that 1 to 5? Can I zoom in? Yes. At least I can try. Okay. All right, and then it's asking me to take the derivative of f. Okay, so I've got d over dx of f. And notice here that f of x here. So I'm going to be estimating we want to estimate f of 4 using the linearization just to kind of put that down. So f of x equals the cube root of x. So we're taking the derivative of, so this equals the derivative here of x to the 1 over 3. And that equals 1/3 x to the 1/3 minus 3 over 3 minus 1. That's going to give me 1/3 x to the negative 2 over 3. Now, normally I would leave it like that, and that's the correct answer. But here, in this case, I'm going to do a little bit more because I know that I'm about to use it for the linearization formula. So what I'm going to do is I'm going to put it on the bottom. So I'm going to do 1/3 x to the 2 over 3. As I said, totally optional, but I know it's coming, so I'm just going to do it. All right, so how do we feel about that little derivative there, 1 to 5? Let's see, multiple choice. This is part B. I need to stop this one now and start. Okay. So how do we feel about that little derivative? Did I do something wrong here? Right, so it's 1 over 3x to the negative 2/3. But what I did was I took this negative and I put it on the bottom. right? So I moved the x to the negative 2/3 to the bottom of the fraction. Okay. Now what I'm going to do is I'm going to use the formula. Yes, so I could, but look at these numbers I'm going to be playing with later, 1 and 8. All right, so, it's actually faster for, I don't know about you. For me, it's faster to work with the exponent form. And I'll show you why in just a moment. Okay, well, I don't have this formula written on my page yet. I'm going to write it here. So I'm going to make this L of LFA. I'm just going to write the formula here of x equals f of a plus f prime of a times x minus a. All right. So what I'm going to wind up with here when I do this is I'm going to wind up with L f1 of x equals, okay, so f of 1 plus f prime of 1 times x minus 1. And so f of 1 is the cube root of 1. That one's easy. Plus f prime of 1 is 1/3 with the 1 to the 1 over 3. This thing, for some reason, what is it called? The parallax is way off on this pen for some reason. It's really annoying me. One over 3x to the 3 times 1 to the 2/3. Times, of course, x minus 1. And 1 to the 2/3 is a nice little convenient number. That's 1. So I get 1 plus 1/3 times x minus 1. And I'm going to leave it like that. I could simplify it, but I'm just going to leave it there. For the other one, sorry, the pen's, again, the pen is really bugging me. f8 of x equals f of 8 plus f prime of 8 times x minus 8. All right, f of x, so this is 8 to the 1/3 plus 1 over 3 times 8 to the 2 over 3 times x minus 8. Now, the reason why I want to leave this, it's now stopped responding. There it goes. The reason why I wanted to leave this in notational form, remember what 8 is. 8 equals 2 times 2 times 2. So 8 to the 1/3 equals 1/3 of the 2-ness. Okay? And 8 to the 2/3 equals 2/3 of the 2-ness. And that's why I find it faster to work in the exponential form, because I could skip the whole squaring of 8 and then taking its cubed root, or taking its cubed root, which is 2, and then squaring it. I mean, that's not a lot of work. But for me, knowing that 8 is 2 times 2 times 2, I want 1/3 of the 2's. Okay, that's 2. And I want 2/3 of the 2's. Well, that's 2 times 2, that's 4. So I'm going to wind up with 2 plus 1 over 3 times 4, x minus 8. And I'm going to leave that. And the reason I'm going to leave it is I have a hankering, since I know I'm going toward 4, I have a hankering that some of the stuff is going to end up canceling. So I can avoid some division if I just leave it. All right, so How do we feel about that 1 to 5? So this is question 1, parts C and D. Okay. Now, if I look at this, just to like the lines I've drawn here, this line right here happens to be LF1 of x. You didn't have to write that, but that's what that line is. And this particular function here, this line, represents the function LF8 of x. Try a different nib. All right. So now what I want to do is, notice I want to estimate I don't want to estimate f of the cube root of 4. I want to estimate f of 4. Okay? I don't think any nib's going to fix this. So what I'm going to do is I'm going to plug 4 into each of these equations. So that means here LF1 of 4 equals 1 plus 1/3 4 minus 1. Oh, isn't that convenient? Equals 1 plus 1/3 times 3 equals 1 plus 1 equals 2. And if you look at the graph, that makes sense there, right? I mean, that estimator right there gives you about 2, that line. Likewise, if I do LF8 of 4, I wind up, so LF8, this was 2 plus 1 over 3 times 4. 4 minus 8, which is going to equal, this is going to become negative 4. 2 plus 1 over 3 times 4 times negative 4. Oh, isn't that convenient? Which equals 2 plus, 2 minus, because I've lost 1, minus 1 over 3, right? It's negative. So that's 6 over 3 minus 1 over 3. I'm going to wind up with 5 over 3. Okay. So 1 to 5, how do we feel about those two substitutions? The common mistake here is to put in the cube root of 4 into your linearizations instead of 4 itself. You're trying to estimate f of 4. F of 4 is the cube root of 4. And so that's kind of the common mistake. All right. And the last thing would be, without putting the cube root of 4 into your calculator, I think I'll have overestimates. Because the tangent lines run above the curve. Okay. You could also say because it's concave down, that means the exact same thing. Okay. All right. Are there any questions right now about this one, about this problem? So how do we feel, 1 to 5? Okay. Any questions? Anybody? All right. Okay, so now I have a graph problem, and I'm going to start this like I start every graph problem. I'm going to start it by saying what's what. So this is 4, f of 4 equals 1. That means 4, 1 is on the curve. F of 2 equals negative, f of negative 2 equals negative 2. That means negative 2 is on the curve. F prime of negative 2 equals 1. Slope of 1 at x equals negative 2. F of 1 is defined. Okay, so 1y exists. F prime of 1 does not exist. So that means I need a jump or kink. And if x is greater than 1, so the slopes are negative for x greater than 1. X is decreasing after 1. Okay. So let's see. 4, 1 goes on the graph. There's 4, 1. Negative 2, 2 goes on the graph. There's negative 2, 2. There's slope of 1 here. I'm going to write that down. F of 1 is defined, okay. F prime of 1 does not exist, so I'm going to have jump or kink. I don't have anything that says it has to be continuous, so a jump or a kink will work. And then I need it to be decreasing after 1. So everywhere here, I'm going to want it to go down. Okay. Yeah, it needs to be sloped down. So everywhere after 1, it needs to be going down. The slope needs to be going down. The slope of the tangent lines need to be decreasing, which means my whole function is decreasing. Okay, so how do we feel about the conditions there, 1 to 5? Let's see, polling, multiple choice. Stop, start. Okay. All right, now for 1 here. Okay, these are done. These are done. The slope of at least of 1. Okay, so I've got these two kind of things going on here. I've got this thing wants to go up here, and it needs to go down once it reaches this point. So a couple things I could do. I could do let's do a slope of 1 here. Right? I don't have anything on either side of this negative. So let's just handle the negative side first. So let's, pull out a 45-degree angle there. And let's stick a slope of 1 going on here. Oops, that's under. There we go. There's a slope of 1. All right, and now I need it to be decreasing, but there's nowhere in the middle that says I need continuity. It only says that I need it to be differentiable after 1. Let's make it decreasing. So I'm going to stick that up there. Who cares, really? I'll just stick that there. It doesn't have to be like that. I'm going to stick this there. This is my function. I'll do what I want with it. Thank you very much. I'm going to stick that there. And now I need it to do something. I just want to fill this in. So I'm going to define 1 right there. And I'm just going to do like this. Why not? It's my function. I can make it happen. Like I want it to. And now I'm going to check. So did I meet my conditions? Is f of 4 equal to 1? Yes. Is f of negative 2 equal to negative 2? Yes. Is f prime of negative 2 equal to 1? Yes, there's a slope of 1 there. Right? I could have made it, have a little bit of curve. Right? I could have made it do something like this. I could have made it do something like that. As long as the slope was 1 there. Or drew a nice little tangent line. Is f of 1 defined? Yep, there it is. Does f prime of 1 not exist? Yep. See, I got to jump. No, it's not differentiable there. If x is greater than 1, then f of prime of x is less than 0. Yes, it is decreasing. The slopes will always be negative. Here, they're exactly negative 1 forever. After I get past 1. Okay, so how do we feel about that? So let's see. Stop. Start. Okay. Are there any questions here? Comments, issues, suggestions, thoughts? I did the graph a little bit differently in the first class, so if you wanted to check that out, you can. As it's on Twitch now. I haven't had a chance to do it to YouTube. It's one of those days, right? Where you keep getting emails. Okay. All right. So I'm going to go ahead and stop streaming. Bye, everyone who's not in my class. Nice talking to you.